Hello everyone. When mentioning the sun, people often think of an endless source of life, but few truly understand the complex journey that created this vital star. Throughout human history, there have been legends and religious stories surrounding the sun, but none of them can deny one fact: the sun is an essential source of energy for life. So how did the story of the sun begin? Where did this star come from, and how did it become the center of the planetary system we call home? Every star in the universe, including the sun, begins as clouds of gas, primordial masses of matter drifting in space. When these gas clouds accumulate enough mass, gravity causes them to compress, leading to the formation of stars. On a galactic scale, the sun is just an ordinary star. It is neither too large nor too small, and it is certainly not the brightest star in the Milky Way. Yet this ordinariness does not diminish its special role in sustaining life on Earth. The sun was formed from the remnants of a massive star that exploded in the past, a violent supernova event. This star is referred to as the pre-sun star. After it exploded, its remnants spread across space, forming a pre-solar nebula cloud. The heavy elements and dust particles within this nebula became the raw materials for the formation of the sun and the planets in the solar system. Although we cannot directly observe the pre-sun star, studies of the chemical composition within the solar system have revealed many intriguing insights. From samples collected on Earth, the Moon, and even asteroids, scientists have discovered elements such as uranium and thorium, radioactive elements that can only be produced by massive supernova explosions. Furthermore, the presence of heavy metal elements like iron and gold also serves as evidence that the sun and its planets were born from the remnants of a giant star that met a violent end. Modern astronomical observations have deepened our understanding of similar supernova explosions. For instance, the Crab Nebula, with a diameter of over 1,800 light-years, is the result of a star explosion that occurred about 1,000 years ago. These explosions not only release enormous amounts of gas and dust, but also produce the essential elements for life, scattering them across space. After the pre-solar nebula released its energy and began to cool down, it became a gathering place for gas and dust under the influence of gravity. However, the sun was not born immediately. The dust clouds underwent a process spanning millions or even billions of years, gradually cooling and condensing into new stars. A prime example of this process is the Orion Nebula, located approximately 1,400 light-years away, which remains one of the most active star factories observable in our local universe. In the Orion Nebula, young stars are forming that are up to 40 times more massive than the sun. These stars emit intense radiation, heating the surrounding dust clouds and blowing away excess material. This is also why the space around newly formed stars often becomes clear and transparent after their formation. Although it was born from dense clouds of dust, the space surrounding the sun today is relatively transparent. This is the result of high-energy radiation and particle streams that the sun has emitted over billions of years. The intense heat and solar winds have prevented the crystallization of nearby dust clouds, making the sun an independent star with no close stellar companions in its immediate vicinity. However, not all stars share this fate. In some cases, stars that form close to one another can create binary or trinary star systems where they orbit a common center. For this to happen, the conditions during their formation must be extremely specific and finely balanced. In the vast expanse of the universe, all stars originate from massive gas clouds, but not every star can shape a planetary system like the sun has. For the sun and the planets in the solar system to form and develop, every component had to align under rare and special conditions. This required stars and planets to crystallize simultaneously, grow together, and shine together. The stellar effects of a young star can destroy the formation process of any celestial body nearby, making the creation of a stable planetary system even more extraordinary. In the solar system, the stellar effects of the sun are vividly evident. Solar winds stripped away Mercury's atmosphere, leaving the planet with an exposed, barren core. While we do not know every precise detail of how the solar system came into existence, scientists have observed and studied stars forming elsewhere in the universe to construct a highly plausible model that applies to the Sun and many other stars. The journey of a star can vary significantly depending on its mass, but all follow the universal laws of physics. Currently, the stars near the solar system are distributed quite sparsely, ranging from 4 to 10 light-years away. Each star carries its own story of lifespan, from young stars like Sirius at only about 230 million years old, to ancient stars such as Lalande 21185, over 8 billion years old. Some stars, like Proxima Centauri or Alpha Centauri, have lifespans similar to the Sun, ranging from 4 to 6 billion years. This has led scientists to speculate that they might have originated from the same molecular cloud that gave birth to the Sun. The pre-solar molecular cloud, believed to have spanned up to 200 light-years, served as the birthplace of everything in the solar system. This was not merely a collection of primordial gas, but also contained elements produced by supernova explosions. These explosions enriched the cloud's chemical composition with heavy elements, such as iron and gold, accelerating the crystallization process necessary for the formation of a stellar core. Radio telescope studies beginning in 1951 detected signals from the voids between stars, revealing the remnants of molecular clouds, though they are extremely faint and difficult to observe. However, most of the pre-solar molecular cloud has long since disappeared, leaving only scattered molecules hidden within the interstellar medium. Based on physical principles, the pre-sun star likely met a dramatic end, such as a supernova explosion, before completely dissipating. Large supernovae or neutron star mergers can produce elements heavier than iron, which are essential for the formation of planets and life. In rare cases, massive stars can explode without leaving any remnants behind. Regardless of the mechanism, the pre-sun star contributed its entire mass to create the Sun and the solar system as we know them today. Currently, the Sun is considered a second-generation star in the universe, a generation of metal-rich stars capable of supporting life. The Sun's energy not only sustains life on Earth, but also serves as the foundation for every food chain on the planet. Plants, algae, and photosynthetic bacteria capture sunlight to synthesize glucose, which becomes nourishment for other organisms. Fascinatingly, when we consume plant-based or animal-based foods, we are essentially absorbing sunlight in a different form. It is no coincidence that throughout human history, the sun has been regarded as a sacred symbol. Pharaoh Akhenaten, one of the most renowned rulers of ancient Egypt, revered the sun as the supreme deity, the source of all life. From a scientific perspective, he wasn't wrong. The sun is indeed the center of the solar system, not only in a physical sense, but also in biological and cultural terms. The sun, with its endless light and energy, governs every aspect of life on Earth. More importantly, it serves as a reminder of the universe's extraordinary journey, where every atom in our bodies originates from stars that long ago ceased to shine, but once illuminated the distant skies.